Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover the topic on maxima and minima of functions of two variables. So what is an extreme value, what is saddle point, how to find the maxima and minima for functions of two variables, that I am going to cover in this lecture. First, let us see the definition. Let f of x comma y be a function of two variables x and y. Then the point f of a comma b is said to have either maximum or minimum if f of a comma b is greater than f of a plus h comma b plus k, or f of a comma b less than f of a plus h comma b plus k. If this value is greater than this, we say that it has maximum value, and if f of a comma b is less than this value, then we say that the function has minimum value. So let us see what is extreme value. The point f of a comma b is said to be an extreme value of the function f of x comma y if it is either maximum or minimum. Any one of this maximum or minimum, that is called extreme value. Now, necessary condition for maximum or minimum of the function is, this is find dou f by dou x and substitute the point a comma b in that, equal to 0. F suffix y, this is suffix y, so this can also be written as dou f by dou y at the point a comma b. So this also equal to 0. This is one equation, this is another equation. If we solve this, we get maximum and minimum values at the given points. Let us see what is a saddle point. It is the point where the function is neither maximum nor minimum. Either maximum or minimum means it is called extreme value, and neither maximum nor minimum means the at that point is called saddle point. The point where the function doesn't have maximum value or minimum value, that particular point is called as saddle point. Now at such point, f is maximum in one direction while minimum in another direction, so we don't have neither maximum nor minimum values. Now let us see, to find the extreme values, that is either maximum or minimum, how to find this function, how to find the maximum or minimum value for z equal to f of x comma y. So step 1 is find the first order partial derivatives, that is dou z by dou x and dou z by dou y, or we can say that dou f by dou x, dou f by dou y. And dou f by dou x or dou z by dou x find and equate to 0, we'll get one equation, and dou z by dou y you equate to 0, we get another equation. By solving these two equations, we get the values of x and y at which we find maximum or minimum value. So these are the points. For each solution obtained in step 2, these are the notations. Dou square f by dou x square means r, dou square f by dou x dou y means s, and dou square f by dou y square means t. So these are three second order partial derivatives. Now if rt minus s square greater than 0 and r less than 0 at any particular point, say a comma b, then the function has maximum value at this point a comma b, right? Second b point, if rt minus s square greater than 0 and r is also greater than 0, then at this point a comma b, the function z has minimum value. So first one is either maximum or minimum, rt minus s square should be greater than 0, right? If r is also greater than 0, the function has minimum value at the point, say whichever point you substitute at that particular point. And if r is less than 0, then z has maximum value. To get maximum or minimum, compulsory this value rt minus s square should be greater than 0. Suppose at any particular point a comma b, if rt minus s square is less than 0, then z has no extreme value. Extreme value means either maximum or minimum. If rt minus s square less than 0, we can conclude that the function doesn't have maximum value and minimum value. And suppose if rt minus s square equal to 0, the case is doubtful and requires further investigation. We cannot conclude that. Now let us see one problem on it. Find the extreme values of this function f of x comma y. How it is given? X cube plus y cube minus 3axy. So first let us find dou f by dou x. So dou f by dou x means x cube derivative 3x square, y cube means with respect to x it is 0, minus derivative of 3axy is minus 3ay. Similarly, differentiate f with respect to y. So we get fy is 3y square minus 3ax. After finding these two equations, equate these to 0. Dou f by dou x equate to 0. So what will get? 3x square minus 3ay equal to 0. Similarly, dou f by dou y equal to 0. So we get 3y square minus 3ax equal to 0. So from first equation we get x square minus ay equal to 0 by taking 3 common. Second equation, this can be written as y square minus ax equal to 0. So from first equation we have y is equal to x square by a, that you substitute in second this equation. That implies we get x into x cube minus a cube equal to 0, which in terms we get either x equal to 0 or x equal to a. If x equal to 0 we get y equal to 0, and if x equal to a we get y equal to a. Therefore there are two stationary points. One point is 0 comma 0 and another point is a comma a. So at this point 0 comma 0 and a comma a, we have to check whether the function has maximum or minimum value. For that we require RST. R means what? Dou square f by dou x square, and S means dou square f by dou x dou y, and T means dou square f by dou y square. Find the values of R, S, T and substitute this point 0 comma 0. So we can clearly see that at the point 0 comma 0 RT minus S square is minus 9a square. Here R is 6x. S means we can write this function S as dou by dou x of dou f by dou y. So dou by dou x of, what is dou f by dou y? 3y square minus 3ax. So if you differentiate with respect to x, you get minus 3a. So this is minus 3a. Similarly, find the another second derivative, dou square f by dou y square, that is t. So we get this value also 6y. So rt minus s square is r into t minus s square. We get minus 9a square at the point 0 comma 0. Therefore we get at 0 comma 0 rt minus s square value is 27a square greater than 0. So f has extreme value at the point a comma a and at the point 0 comma 0. So the minimum value is, if you substitute the point 0 comma 0, we get rt minus s square less than 0. So if rt minus s square less than 0, we say that the function has neither maximum nor minimum. And if at the point a comma a, we got rt minus s square as greater than 0. So if in this 27a square there should be different cases. If a greater than 0 and r is also greater than 0, then the function has minimum value, and that minimum value is say minus a cube. How we got this? Substitute the point a comma a in the given function. What is the function? X cube plus y cube, x cube plus y cube minus 3axy. Substitute a, x equal to a and y equal to a. So a cube plus a cube minus 3a cube. So this is minus a cube. Similarly, if you substitute a comma a where a is less than 0, then we say that the function has maximum value at the point a comma a, and the maximum value is plus a cube. Let us see one more problem. Find the maximum and minimum values of x cube plus 3xy square minus 3x square minus 3y square plus 4. So to find maximum or minimum value, first of all we have to find dou f by dou x, that is 3x square plus 3y square minus 6x, and let it be equal to 0. And dou f by dou y, you find out this and equate to 0, which will be getting as this is 6xy minus 6y equal to 0. So this is first equation, this is second equation. So from this, if you take 6y common, x minus y equal to 0. So either 6y equal to 0 or x minus y equal to 0. So x equal to y. So y equal to 0 or x equal to y. Sorry, x minus 1 equal to 0. So x equal to 1. Suppose if you write y is equal to 0 from equation 1, what can we write? Substitute y equal to 0. So we get 3x square minus 6x equal to 0. So from this, if I take 3x common, x minus 2 equal to 0, that implies either x equal to 0 or 2. We get x equal to 1. If x is equal to 1, substitute x equal to 1 from equation 1. So we get 3 plus 3y square minus 6 equal to 0. That implies 3y square minus 3 equal to 0. So if you take 3 common, y square minus 1 equal to 0. So y square equal to 1 means y is equal to plus or minus 1. So what are the points here we have? If we have y equal to 0, x equal to 0, that is, and if y equal to 0, x equal to 2, so the point is 2 comma 0. And if x equal to 1, y equal to 1, so 1 comma 1 and 1 comma minus 1. So these are the points. Now at which point we have maximum and at which point we have minimum, that we have to find. So for that we require r, st values. So r means what? Dou square f by dou y square. So that is, differentiate this with respect to x. So this is 6x minus 6, and s is equal to dou square f by dou x dou y. This can be written as dou by dou x of dou f by dou y. That is dou by dou x of, what is dou f by dou y? 6xy minus 6y minus 6y. So if you differentiate this with respect to x, we get 6y. And coming to t equal to dou square f by dou y square, that is dou by dou y of 6xy minus 6y. We get minus 6. Sorry, this is 6x minus 6. Now At the first point, say 0 comma 0, rt minus s square value. At 0 comma 0, this value is minus 6. R into t, x equal to 0, substitute, you get minus 6 rt minus s square. 6y, y equal to 0 means 0, that is 36, which is greater than 0. So we got rt minus s square greater than 0. One condition is satisfied. Now we don't conclude whether we have maximum or minimum only based on this. Also, what is r here? 6x minus 6, and in place of x substitute 0. 6 into 0 minus 6, that is negative 6, which is less than 0. Therefore the function has maximum value at the point 0 comma 0. How to find the maximum value? Substitute x equal to 0, y equal to 0 in the given function. So if you substitute, all these terms will be getting 0 and we get 4. So, and the maximum value is 4. Similarly, at this first point we got at 0 comma 0, this point we get maximum value. Now consider the second point 2 comma 0. At 2 comma 0, rt minus s square, we get 0. Therefore the function f has minimum value, and minimum value is, substitute x equal to 0, y equal to, sorry, x equal to 2, y equal to 0, that value we get as 0, right? Find three positive numbers whose sum is 100 and whose product is maximum. Let us take sum of three numbers is 100, let it be some k, and whose product is maximum. So f is equal to f equal to xyz. So for which we find dou f by dou x, that is xy into, from this equation z is equal to k minus x minus y. So in place of z we can write it as k minus x minus y. So this can be written as xy into, okay, dou f by dou x means with respect to x you differentiate this and equate to 0, let it be equation 1, and dou f by dou y equate to 0, let it be equation 2. By solving equations 1 and 2 we get the values of x and y, that let it be k by 3. So x equal to k by 3, y equal to k by 3. The point is k by 3, k by 3, right? Now find rt s square. R means what? Dou square f by dou x square, and s means dou square f by dou x dou y. T means dou square f by dou y square. Then find rt minus s square, that is greater than 0, and we get r value less than 0. Therefore the function has maximum value and at the point k by 3 comma k by 3, right? So substitute x value, y value, we get z is also k by 3 and z is also k by 3. Thank you.